So hi, my name is TC, and along with my partner here, Kim, we will be doing the video for our HBL's EM2B. Alright, so I'll be starting off first by doing the first part. Alright, so we are required to find the Taylor series for the function cosine 1 over 2x about x equals pi by following the scaffolding steps. Alright, and here is the Taylor series which we are supposed to use, and let's work out the terms. So the first one has been done for us, fx equals cosine 1 over 2x, and then for the second one, f prime x will be equals to negative 1 over 2 sine 1 over 2x following with 2x and then 1 over 8 sine 1 over 2x. Yep, alright. So the first three terms followed by substituting x with pi. We get, for the first one, by substituting x with pi, we get 0. For the second one, we get negative 1 over 2, that 1, 0, and the fourth one is 1 over 8. Alright, so with that, we shall sum it up. Alright, so cosine 2x. So first one, just write the first one. So it equals cosine 1 over 2 times 8. Wait. Rub it off, sorry. So with that, the first term is 0 plus f prime e, which is negative 1 over 2, times x minus e, which e is pi, plus f double prime e, which is 0 over 2 times x minus pi square, f triple prime, which is 1 over 8, over 3 times x minus pi cube, and so on. Right, so from there we summarize it out. We get negative 1 over 2 times x minus pi plus 0 as f double prime is 0 plus 1 over 48 times x minus pi cube. Yeah, right. Then finally we get 1 over 2 minus pi plus 1 over 48 x minus pi cube to infinity. Alright, so from here onwards we will be going to with our final function, which is negative 1 over 2 bracket x minus pi plus 1 over 48 times x minus pi cube. We will take this and put it into our Desmos calculator. Okay, so by pumping in the equations given, we have our two graphs. Right, so the first one will be the one whereby y equals 1 over 2x, and the second one is the equation we got after we have our three terms. Alright, and with that we managed to generate two graphs. The first one is the original one, and the second one is the Taylor series one. So first question, do the two graphs look exactly the same, and where do they look the same? Right, so these two graphs, they are not identical, however they look similar, as in the range of convergence is around 0.2, 0.4 onwards. Yeah, And so what can you do to make the two graphs look more similar? We can add more terms to the graph so that we can add more terms to the equation, Taylor series equation, so that the new graph that's generated will be closer to the original one. Yep, and with that, I'll be passing on to my partner Kim, which we will talk more about the next part.
So for the second part of the assignment, we have to continue the equation, the Taylor series, by adding more terms to it. So the first one will be 1 over 16 cosine half x. The second one will be negative 1 over 36 sine half over x. Third one will be negative 1 over 72 cosine half x. Then the last one will be 1 over 144 sine half x. So we have to sub in now the x value as pi. So the first one will be 0. Second one will be 1 over negative 36. Third one will be 0. And the last one will be 1 over 144. Now we have to complete the equation now from the previous one and up to now. So it will be copying from the first equation, it will be half bracket x minus pi plus 1 over 48 bracket x minus pi close bracket cube. Then it will be 1 over 4320 bracket x minus pi to the power of 5. And then last one will be 1 over 725,760 bracket x minus pi to the power of 7. So from here, we have to convert this equation to the graph. So the next part of this assignment is that to generate the final equation that we have. So as a recap, the red one symbolizes the original function. The second one is this first part of the Taylor series, and the green one, which is the third one, is our final Taylor series where we add in more terms. So as you can see, this is the graph that we have. So from this graph, the first question will be, does the new graph look more similar to the graph of y equals to cosine half x, and where do they look the same? So yes, it is similar from negative 1 onwards, and this is called the interval of convergence. Secondly, what conclusion can you make about the approximation of the functions using Taylor series? The more terms that it has, the closer it is to the original one, which is the red one. And lastly, the three graphs seems to be exactly intersecting at x equals to pi. Why do you think that is the case? At x equals to pi, for the function cosine half x, that is called the point of convergence. So that sums up our HBL assignment. Thank you for listening.